Okay, everybody, happy Sunday. This is your mole test review. Your test, of course, is tomorrow. So here we go. How many particles are there in one mole? Well, here's the answer 6.02 times 10 to the 23rd particles. Pretty standard, that is the mole. Empirical formula for B4O8. Well, B4O8 is a molecular formula and it can be reduced. You look at the subscripts and we see that the 4 and the 8 can be reduced down. They both have a 4 in common. 4 divided by 4 is 1. 8 divided by 4 is 2. Comes out to be BO2. All right, number 3, write two molecular formulas for P2O5. Well, P2O5 is your empirical formula, so we can multiply both those numbers by 2. And if we do that, we get P4O10. We can also, to do another one, we can multiply each number by 3 if we wanted to. And we could say P6O15. Those are just two more molecular formulas for that empirical formula. Number 4, how many particles are there in 4.52 moles of sodium hydroxide? That's a one-step problem. You write down what you've been given, 4.52 moles. And 1 mole will go down here. And 6.02 times 10 to the 23rd particles will go on top. That's according to your flow chart that you're needing for tomorrow. And so if we solve this, 4.52 times 6.02 times 10 to the 23rd, that gives us 2.7 times 10 to the 24th, 2.7 times 10 to the 24th particles. Okay, making sure we box our answer that we can see that. Number 5, how many atoms are there in 17.7 moles of titanium? Another one-step problem. Write down what you've been given, 17.7 moles. And you're going to atoms, so again, you're going to be multiplying by Avogadro's number, 6.02 times 10 to the 23rd atoms. And you solve that problem. 17.7, oops, let me clear that out, 17.7 times 6.02 times 10 to the 23rd. That gives us 1.07 times 10 to the 25th. And that would be atoms, making sure that we have units for our numbers. Okay, how many grams of calcium carbonate are there in 3.62 moles of calcium carbonate? Well, it's a one-step problem, but you're moving from moles to mass. And we have to have the molar mass of calcium carbonate. So let's do this. Let's set it up first and put 3.62 moles here and 1 mole down here. And we're going to multiply by the molar mass of calcium carbonate. Calcium happens to be 40. I'm just rounding right now. Carbon is 12. Oxygen times 3, that would be 48. So it's 10, 5, 6, that's 100. So 100 grams of calcium carbonate, and that's going to give us 362 grams of calcium carbonate. Okay. Number 7, how many moles are there in a 36.4 gram sample of magnesium chloride? Moles to grams, again, that's a one-step problem. Write down what you've been given, 36.4 grams. And we are going to, divide this time. So we're going to have 1 mole on top, and we're going to have the molar mass of magnesium chloride. Magnesium happens to be 24. I'm rounding again. Chlorine is 35. I'm going to round it down to 35, so that's going to be 70. That's going to be 94. So I'm going to put 94 down here. 36.4 divided by 94, and it's going to give me 0.39 moles of your magnesium chloride. Okay, box the answer. All right. Number 8, a 63.5 gram sample of diphosphorus pentoxide contains how many molecules? Two-step problem. So we're going to go like this. Write down 63.5 grams. That's ugly, but I'll just leave it there. and we need to get the moles first. So you go from the gram to the mole. So we have to have the mass of P2O5, that's oxygen times 5, which is going to be 80. And that's going to add that to 2 phosphorus atoms, which is going to be 62. That's going to be 142. So 142 grams is going to go here. 1 mole is going to go up on top. Then we do that. And we're going to put 1 mole on the bottom because that's what our flow chart tells us to do. And it also tells us to put 6.02 times 10 to the 23rd molecules on top. I'm going to abbreviate that. And when we solve this, thing, it's going to be 63.5 times 6.02 times 10 to the 23rd. And divide that by 142. Gives us 2.7 times 10 to the 23rd molecules times 10 to the 23rd molecules. So there we are there. All right. We have another 2-step problem. Atoms. We're trying to find atoms in this one because it says how many atoms in a 59.6 gram sample of tin. So again, we set it up this way, 59.6 grams, and the mass of tin is 118. We'll make it 119 grams, and put 1 mole on top. Then we put 1 mole back on the bottom because our flow chart tells us that, and then Avogadro's number on top. Okay, so now it's 59.6 times 6.02 times 10 to the 23rd equals, and then divided by 119, and it's going to give us 3.02 times 10 to the 23rd atoms here in the boxing answer. Okay, you're going to have percent composition test. Here it is. Percent composition is simply the molar mass of the copper in this case divided by the molar mass of the copper sulfate times 100. So it'd be 63.5 grams divided by 159.6 grams times 100. And so you calculate that out, 63.5 divided by 159.6 equals times 100 equals 39.8% of the copper in that copper sulfate. Number 11, the empirical formula of the compound is C2H3O. What is the molecular formula? If the molecular mass of the compound is 215 grams per mole. So the first thing you have to do is calculate the molar mass of your C2H3O, and it's 43 grams. It's kind of rounded there. So you're going to take that, and you're going to divide that number, 43.0, divided by 215.2 grams, and that's going to give us a number, oops, wrong way, sorry, 215.2, other way, guys. That was percent composition I was trying to do. So 215.2 grams divided by 43 grams, okay? And that's going to be 5. So we can take this number, and we're going to go back to our empirical formula, C2H3O. And we're going to multiply everything in there by 5. And when we do that, the C2 now becomes C10, the H3 becomes H15, and the O becomes 5. And there is our molecular formula. Number 12, molar mass is determined from your periodic table. That's where you get it from, the mass number on the bottom. There are 3 true things about the mole. Here they are. And they are, it is the System International unit for an amount of a substance, basically the same the metric system. 6.02 times 10 to the 23rd particles, that's what the mole contains. And then molar mass can be found on the periodic table. Okay. 14, if you have 1 mole element, how many atoms do you have? Well, you have 6.02 times 10 to the 23rd atoms. 2 more. Empirical formula, the simplest whole number ratio of atoms present in a compound. So H2O is an empirical formula, and SO over here is an empirical formula. You cannot reduce those subscripts down any further for either one of those. The molecular formula shows the exact number of atoms in a molecule of a compound. Like if we had H2O, that we could make that a empirical molecular formula by saying H4O2, and SO could be S2O2 as an example. Also, here's another one, C2, let's not use that. Oh, so C6H2O6, no, let's not do that. H2O2, H2O2, that's a good one. That is hydrogen peroxide. Everybody knows hydrogen peroxide, H2O2, and that's another example of a molecular formula. Okay, the math is pretty straightforward. Practice it. We'll see you tomorrow. Bring your periodic table, bring your flow chart, and have a good night.